So, let's talk about one of the biggest headaches in the entire tech world, trying to figure out how long a software project is actually going to take and what it's going to cost. It's a puzzle that has been around forever, and today we're going to look at one of the most famous attempts to solve it.
I mean, we've all seen this happen, right? You start a project, everyone's excited, the plan looks solid, the deadline seems totally reasonable, and then, somehow, everything just goes off the rails. It's this universal pain that sets the stage for everything we're about to talk about. Well, way back in the day, a researcher named Barry Boehm got, pretty fed up with this exact problem. He was working at TRW Aerospace, and he started digging into the data from 63 different projects. He was looking for a pattern, some kind of formula that could bring a little bit of order to the chaos. And what he came up with was the Constructive Cost Model, or as pretty much everyone calls it, COCOMO. The idea is that it gives you a step-by-step process for making an estimate. And the most important part, it's not just pulling numbers out of thin air. It's all based on data from real projects that had already been completed.
And the idea at its heart, it was actually kind of revolutionary because it was so simple. Boehm suggested that the single best predictor for how much work a project would take was just its size. And how did he measure size? By the number of lines of code that needed to be written.
All right, so let's really get into it. To understand what makes this model tick, we need to look at where it came from and how it works on a basic level.
You see, this wasn't just a one-and-done thing. The first version, which we now call COCOMO 81, was built using data from projects in the 1970s. And back then, pretty much everyone was using the very rigid, step-by-step waterfall method. But of course, technology changed a lot. So by the year 2000, the model got a major update, becoming COCOMO II, which was based on data from 161 more modern projects.
Okay, so here's where it starts to get really interesting. COCOMO understood from the very beginning that not all software projects are the same. So Boehm came up with 3 distinct project personalities, and which one you chose would totally change the math.
So you have to ask what you're building. Is it a pretty small, simple business system with a team that knows what they're doing? Well, that's an organic project. What about a new database system, something a bit more complex with a mix of experienced folks and newbies? That's semi-detached. Or are you building something like flight control software, super complex with crazy strict requirements? That's embedded. Each category actually uses a different set of numbers in the formula because the effort just doesn't scale up the same way for each one. But, it's never that simple, is it? You could have 2 projects with the exact same size and type, but one finishes on time and the other is a total disaster. The basic model needed more.
And that's exactly why the intermediate COCOMO model was created. It paints a much more realistic picture by bringing in these things called cost drivers.
You can think of these cost drivers as dials you can turn to adjust your initial estimate up or down. There are 15 of them, and they cover everything from how reliable the product needs to be to, and this is a huge one, how skilled and experienced your team is.
And this is where you can really see the power of the model. Just look at the impact of one driver, analyst capability. If your analyst skill is rated very low, the model says, bam, your effort estimate shoots up by 46%. That's a massive increase. But if you have a very high capability analyst on your team, the required effort drops by almost 30%. This shows that team skill isn't just some vague nice to have. It's a real quantifiable factor.
But of course, time marches on. By the 1990s, the way people built software was completely different. We'd moved on from giant mainframes to desktops, and ideas like reusing code were becoming standard practice. The original COCOMO was starting to look a little outdated.
So this huge shift in technology meant the model had to adapt or become irrelevant. And that's what led to COCOMO II, which was completely redesigned for the world of modern software engineering.
So one of the really clever innovations in COCOMO E was the idea of scale factors. Instead of just lumping a project into one of those 3 big categories, these 5 new factors created a much more precise scale. They measured things like how well the team works together or how mature the development process is, to better predict how effort would grow as the project got bigger.
And these scale factors help us model something absolutely critical called diseconomies of scale. It's a fancy term, but the idea is simple, and this graph shows it perfectly. For complex projects, if you double the size, you don't just double the effort, it can more than double. It's like building with Legos, right? Building 2 small, separate houses is easy, but trying to combine them into one giant mansion, that takes way more planning, and all the teams have to talk to each other. That communication overhead just explodes.
Another massive change COCOMO II had to deal with was software reuse. We don't write everything from scratch anymore, but the model was smart enough to recognize that just because you're reusing code, it doesn't mean it's free.
Honestly, this is one of the most brilliant insights from the whole thing. The cost of reusing code is not a straight line. As you can see here, there's a cost just to get a component and plug it in. But here's the shocker. If you need to modify that reused code, even just a little bit, say changing 20% of it, it can cost you more than half of what it would have cost to just write the whole thing yourself from scratch. Why? Because of the massive effort it takes just to understand the code you're trying to change in the first place.
So after all that, where do we land? After this whole journey from 1981 to today, what's the final verdict on COCOMO? Let's weigh its legacy against its limits.
Okay, on the plus side, it's fantastic for providing a clear, repeatable process that's based on actual data, and its cost drivers are amazing for helping you spot the biggest risks in your project. But it's definitely got some blind spots. It's only as good as the old project data you feed it, and it doesn't really have a good way to account for things like customer cooperation or complex security needs, which are absolutely huge today.
And that really brings us to the big final question, doesn't it? In our world of agile, AI that literally writes its own code, and super fast prototyping, does a model that was first imagined in 1981 still have a place? Is an estimate based on lines of code just obsolete? Or are the core ideas it taught us about complexity, team skill, and the hidden costs of getting bigger? Are those ideas more relevant than ever, just maybe in a different form? The tools change, but the puzzle of figuring out how long will it take, that's not going away. Thanks for tuning in.